Hello everyone, welcome to YouTube channel Maths Insights. In this video, I am going to discuss very important topic for all competitive examinations and academic classes. That is, what is meant by LCM and HCF. LCM and HCF. Before going deep into the topic of LCM HCF, I want to discuss some important basic points. Those are called multiples and factors. What are meant by factors first? I am taking the word factor. You may have listened this word factor. See, any number is said to be factor to other number if it divides it exactly. I am taking example 24. If you take 24 and if you divide with a number called 6, 6 4s are 24, then it will divide it exactly and the remainder should be 0. Then only you will say that this number 6 is dividing 24 exactly. Then you will say these 6 as factors. See, for 24 there are more factors other than 6 also. 4 is also called a factor. 8 is also called a factor. Why? Because if you divide 24 with 8, 8 3s are 24. So for a number 24, you will find more factors. Then those will become 1 and 2. Why? Because 2 will exactly divides 24 and 3, okay, 4, 6, 5 is not, and 7 is not also a factor, 8, okay, 12 and 24. These are all factors, and if you observe, all these numbers are exactly divides 24. That's why these are called factors. And you have to observe, 1 is factor to every number, and the number itself is also factor to that number. Therefore, for every number, minimum there will be 2 factors. Those are, number 1 is 1 and the second factor is the number itself. Okay, and if you take another number, suppose 36. If you take 36, you will have 1 2 3, okay, 4, not 5, and 6, okay, not 7, 8, 9, 9 is there, not 10, 11, 12 is there, 12 3s are 36. So next, if you write like that, you will find that 18 is one factor, and finally 36. So you will find 1 and 36, minimum 2 factors, and you will find more factors also. Next, if you see the important word multiple. So the name itself says multi-complex means more. Actually, factor is obtained when you divide the number into parts. That means you will get less part when compared to the original number. Here multiple means you will get more, multiple. Our property is multiplied means that has increased. So if you see 2 ones are 2, if you take 2 table, 2 is multiple of 2. Why? Because you are multiplying with 1. So 2 2s are 4. So 4 is also multiple of 2. Why? Because you are multiplying 2 with some number. That means you are making more. That is 2 8 ja. 2 8 ja 16. 16 is called multiple of both 2 and 8 also. Why? Because you are multiplying 2 with 8. That means you are increasing 2 8 times, and also you are multiplying 8 with 2 means you are making 8 2 times. 8 plus 8 will become 16. This is called multiple. Now discussing about LCM. Actually, the full form of LCM is least, okay, least common multiple. So if you want to find LCM of 2 or more numbers, you can find LCM of any number of numbers. I am taking suppose 6 and 9. I am taking 6 and 9. I will write first multiples, then I will find common multiples, then I will select the least common multiple. If you see the multiples of 6, 6 ones are 6, okay, 6 twos are 12, okay, 6 threes are 18, okay, 6 fours are 24, like that. And if you take 9, 9 ones are 9, okay, 9 twos are 18, 9 threes are 27, and so on. See, if you observe the common multiples, you have written the multiples, now we have to take out the common multiples. If you observe 18, okay, 18 is the common multiple, you have 36 also here, okay, multiple of 6, here also you will have 36. So if you select the common multiples 18, 36 and so on, in this common multiples you have to select least common multiple. So 18 is the least common multiple. This is the LCM of least common multiple of 6 and 9. This is exactly divisible by these two numbers. That's why you will call least common multiple. 6 3s are 18, 9 2s are 18. You may find common multiples, those are not important. Whatever the common multiples are there, you have to take least common multiple. This is called LCM. You may find LCM of fractions also, you may find LCM of polynomials also. We will discuss it in this video itself. Next, HCF. The abbreviated, the expanded form of this HCF is highest common factor. Here you are discussing multiples, you are discussing factors. The other name for this also is greatest common divisor. Greatest common divisor. So highest common factor, you may write like this. Otherwise greatest common divisor. I am going to find HCF of these two. See, you have to write the factors. If you write factors of 6 is equals to, you know, 1 and the number itself are the minimum two factors. So I am writing 1 comma 2. 2 will exactly divides 6, 3 and finally 6. Now factors of 9. See 1, okay, 2 is not factor. Next 3, okay, 4 is also not factor, 5, 6, 7, finally you will have 9. Now I have written the factors. You have to take the common factor. See, common factors, what are the common factors? You observe, if you observe, common factors is equals to 1 comma, okay, 3, okay, right, 1 and 3 are the common factors, but you have to take the highest one. What is the highest one? So 3 is the highest one. These 3 is the HCF of the numbers 6 and 9. Therefore HCF of 6 and 9 is equals to 3. See, the HCF will be the small number when compared to LCM. So LCM of 6 and 9 is equals to 18. Okay, in this way you may find LCM and HCF in for more than two numbers also, but this is a traditional method. So we have some ways how to find LCM and HCF. We will discuss that. Mainly there are two methods to find the LCM and HCF. The first one is prime factorization method and the second one is division method. First, you will know what is meant by prime factorization and how to find LCM and HCF. I will take the same numbers to find the LCM and HCF. See, prime factorization, the name itself says that you have to prime factorize the given numbers. What are the given numbers? I am taking another one number, LCM of 6, 9, 12. I am taking three numbers. First you have to prime factorize all these three numbers. You have to write, see, 6 can be prime factors, 2 3s are, you cannot further factorize this one. Therefore 6 can be written as 2 into 3. If you see 9, so 3 3s are 9, this can be written as 3 into 3, that is 3 square, you may write. If you take 12, see 2 6 are 12 and 2 3s are 6, this is called prime number, means you cannot factorize it further, that is the least number which can you divide by using that number. See 2 into 2 into 3, this can be written as 2 square into 3. After prime factorizing all the given numbers to which you are going to find LCM, you have to observe the exponents of the prime factors. You have to take highest factor. What is this highest factor? If you observe 2 power 1, here you don't find 2 power 1, the factor 2, you may write it as 2 power 0 also. Okay, if you observe 2 power 1 is there, 2 power 0 is there, 2 power 2 is there. What is the highest exponent of this prime factor? 2. If you observe 2 square, therefore 2 square into. Next, go to the next prime factor, 3. 3 power 1, 3 power 2, 3 power 1. In this 3 power 2 is the highest prime factor having highest exponent. Then you don't find any other factor, so you have to multiply this. 2 square is 4 and 3 square is 9. 9 4s are 36. Therefore 36 is the LCM of these three numbers, 6 9 12. If you divide 6 6 are 36, 9 4s are 36, 12 3s are 36. There is no least number than this which is exactly divisible by these numbers. You could not find, you may find more than that, that is not least, this is the least. That's why it is called least common multiple. Next, coming to division method. In the division method also you have to write all the numbers. See, this is division method to find LCM. So you have to write all the 3 numbers or 4 numbers, whatever the number of numbers, you have to write like this. You have to divide these all 3 numbers with a common divisor. That is, see, if you take 2 divides 6 and 12 exactly, but not it divides 9 exactly. So you will not take it. You may take it also, but you have to write 2 3s, you have to write the quotient here. And if you cannot divide this number exactly, you have to write as it is. And 2 6, you have to write like this, but you have a common divisor which divides all this exactly, that is 3. I am taking 3, therefore 3 2s are 6, 3 3s are 9, 3 4s are 12. In this case you will divide all this with 2 except 3, therefore 2 1s are, so since you could not divide 3 exactly with 2, I am writing as it is, therefore 2 2s are. If you observe, you cannot divide with any common divisor all these numbers, therefore I am writing product 3 into 2 into 1 into 3 into 2. If you multiply all this, you will get the LCM. See, 3 2s are 6, 6 3s are 18, 18 2s are 36. So 36 is called LCM of these 3 numbers, and you may take more than 3 numbers also. So prime factorization method, division method. Prime factorize every number, take the factor with the highest exponent and multiply all those, then you will get the LCM. Here division method, you have to write every number by putting commas between them and divide with common divisor, and if you could not find common divisor, you have to write the number as it is, then go forward. Finally you will reach a position where you could not divide all the numbers. Those are called prime numbers, and multiply all the numbers, you will get the LCM. Now I want to discuss how to find HCF of numbers by using these two methods. These are the important methods: prime factorization method, division method. I am taking same numbers, okay, 6, 9, 12. You may take different numbers and you may take 4 numbers or 5 numbers, whatever the number of numbers may be. See, in the same manner, you have to prime factorize every given number. If you see, 6 can be prime factorized as 2 into 3. You cannot write any factor for this. So 2 power 1, 3 power 1. Similarly, if you take 9, that can be written as 3 into 3. That means 3 square. So 12 can be written as, this is 2 into 3. That means 2 square into 3. So after prime factorizing all the given numbers, you have to take a factor which is having least exponent. In the previous LCM, you have taken the prime factor which is having highest. Now we have to take least. If you observe, see 2 power 1, okay, here you could not find 2, but I am writing with 2 power 0. 2 power 0 is 1, therefore it will not make any difference, this and this. In these all the three, you will find 2 power 0 is the least, therefore I am writing HCF is equals to 2 power 0 into, next coming to 3, see this is 3 power 1 and this is 3 square and this is 3 power 1. You have to take the least is 3 power 1, therefore 3 power 1. 2 power 0 is 1, 3 power 1 is 3, therefore 3 is the highest common factor. You could not find any other number than this which is highest common factor. Next, coming to division method. In this method, you have to take 3 numbers 6, 9, 12. This is division method. Okay. So in this, you may take any 2 numbers, either 6, 9, 9, 12, 12, 6. First find HCF of those two. After finding the HCF, we find the HCF of the obtained HCF on the remaining number. See, I am taking 6 and 9 first. For 6 and 9, I am finding HCF in the division method. You have to divide the bigger number with smaller number. So 6 ones are 6. Okay. 3. You have to continue the division until you will get remainder 0. You have to divide this 6 with this remainder. So you have to divide this 6 with this remainder 3. 3 2s are 6. You got 0. Now this is the HCF of 6 and 9. After finding this, you have to find HCF of this 3 and 12. Now, therefore, HCF of 6 and 9 is equals to 3. Now, HCF of 3 and 12. In a similar manner, what we did here, you have to divide the bigger number 12 with this 3. Therefore, it divides it 4 times exactly. 3 4s are 12. So, you are getting remainder 0. Therefore, this is the HCF of all the 3 numbers 6, 9, 12. Therefore, HCF of 6, 9, 12 is equals to 3. So, in this way, you may find HCF or LCM of 3 numbers or more than 3 numbers. There is a relation between HCF, LCM and product of 2 numbers only. Let I am taking two numbers, okay? 2 numbers be x comma y. If you multiply these x and y, you will get same answer as when you multiplied HCF and LCM of this x and y. See, therefore, HCF into LCM. Therefore, product of any 2 numbers, okay, is equals to product of LCM and HCF of those numbers. Very simple. Product of numbers is equals to product of LCM and HCF. I am taking 6 and 9. Suppose if you take 6 and 9, LCM will become, LCM is, what is the LCM? Which is divisible exactly with these numbers, that is nothing but 18. Okay, and HCF, if you take HCF, that is 3, just you come across that 3. Therefore, if you multiply two numbers, product of numbers, okay, product of 6 comma 9, that is 6 into 9, 6 9 ja 54, okay, and if you find the product LCM into HCF, that is equals to 18 into 3, that is equal 18 3 is a 54. So in the both cases you are getting same answer. This is very useful in finding the numbers. Here you have x, you have 4 unknowns, x, y, HCF and LCM. They will give you 3 of this, then they will ask to find the 4th one. They may ask x by giving y value, HCF and LCM. By using this relation, you could find either x or y or HCF or LCM. This is very important in competitive examinations. You will do some problems in the next video, then this will become very clear to you. How to find the LCM and HCF fractions? If you want to find LCM of any two fractions, minimum 2 fractions, and you may take more than 2 fractions also. If you want to find the LCM of fractions is LCM of numerators by HCF of denominators. Suppose I will take 1 by 2, 3 by 4, 6 by 7. If I want to find the LCM of these factors, LCM is nothing but you are going to find least common multiple. That means that is divisible by these 3 numbers. First we have to find LCM of numerators. That means LCM of 1, 3, 6 by HCF of denominators. What are the denominators here? 2, 4, 7. Therefore HCF of 2, 4, 7. You will get one answer here and you will get another answer here. The fraction which is obtained so is the LCM of fractions. Similarly, if we want to find HCF of fractions, first we have to find HCF of numerators. That means if you take the same example in this case also, HCF of numerators 1, 3, 6 by LCM of 2, 4, 6. Then you will obtain a fraction which is called HCF of fraction. This is also very important in different competitive examinations. We will discuss more problems, whatever the concepts we discussed in the next video. Don't forget to see that video, then only these concepts will become very, very clear. And I am hoping that this video is very helpful to all of you. If you like my video, kindly subscribe to my channel and share it, like it, and we will meet in the next video. Until then, have a nice day. Thank you.